So to avoid having to use, this is section 6.2, in order to avoid you having to use all those formulas with the permutation and combinations, what I really want to encourage you to do is just use technology for this part of it. We don't need to learn all that. If you want to and go back through it, I'm more than willing to help you do it, but you do not need to. I'm not going to require that you do. Where we're going to go next, this is a piece. So on the homework, I'm going to ask you to do a problem like what you're seeing on the screen. And you want to make sure you go back and review what actually a binomial experiment is. What are the conditions? Because those are important. I won't do that here. I just want to show you how to crunch this. And Excel certainly works great for it. If you know what you're doing with Excel, there's a formula right in. If you type in equals in Excel, if you type in equals here, I can show you as a matter of fact. If you type in equals binomial distributions, what you can do is you can look at the syntax. Again, some of you aren't comfortable with Excel, and I don't want to make you have to learn how to use this for this feature, because there's all other kinds of tools, a lot of other kinds of tools. And one that I'm going to link to in the discussion forum for you this week, or actually in the week 7 homework, is this web page here. And what this does is this will draw a histogram for you. It will do all the calculations for you. So for this problem, what do we have? We have n equals 6, so there's going to be 6 possible outcomes, and the probability of getting a success on each outcome is 0.8, and that doesn't change. So if I go back to my web page here, and I got 6 outcomes, n is 6, and the probability of each outcome happening is 0.8. And then what they'll do is it exactly in a cumulative, at least. I'm not going to have you do that this time. We're going to do is just calculate each individual element. So if I compute that, we see the histogram already. It looks left skewed to me, and we'll look at that in a minute. But in order to construct the histogram, I know when x is 0, there's a pretty small chance of that happening, almost 0. So I would go back to my table. I'll use this spreadsheet and do a new tab. I think I'll do a new tab because I got to get out of that. Okay, so if I have x, we've got 0, 1, 2, 3, 4, 5, 6. Here, let me zoom this out a little larger for you. Okay. Here's the probability. So we already looked and we saw that the probability was almost 0. So I mean, it was so small that I'm not even going to bother typing in all those numbers. Okay, right? When the probability of 6 outcomes of 0. So the next thing we would do is what's the probability of getting 1? So that's a little bigger, 0.0015. So I can go back there and I'm going to type in 0.0015. Then do the web page. Of course, you can write this all down on paper. And 2 is our next thing. So 0.0154. It's interesting why those are the same, almost the same, just by a factor of 10. Okay, and then we're going to go back and so I finished filling this in. I didn't figure guys needed to see me switching back and forth between the web page. And so here's the probability distribution for this binomial experiment. A couple things to check. I mean, they should be. If I add up these probabilities, I should get 1. Oh, I don't. So, yes, it's a teacher question. Why isn't it 1? It's pretty darn close. Well, it's because I rounded some of these numbers, and that's why it's not exactly 1. Okay, so that's the probability distribution. They wanted us to calculate, let's see, let's go back to that page here. What did they want us to do? They wanted us to calculate the mean and the standard deviation. So with those formulas, so to find the mean of these distributions, you use these formulas, and that just means the mean for this distribution, kind of like what we did before, is you just take the sample, or how many trials you're running times the probability of a success in each trial. So it's just going to find the mean. I'm just going to type in 6 times 0.8, and that's the mean, 4.8. Here, I'll drag that off there. And then to get the standard deviation, if you look at this, the formula for the standard deviation is take n times p, which is the same as the mean, times 1 minus p. Some books call this q. So that just means what's 1 minus the probability of a success, which is, for this case, is 1 minus 0.8. So if you think about 1 minus 0.8, that's going to be 0.2, right? So I just got to take, start at the beginning, or you can just take 4 times 0.8, or I could have taken the 4.8. I'm going to multiply that by 0.2. And then I got to take the square root of that, and there's a lot of ways to take the square root. I'll use this key here. Okay, the square root of 0.96. So that's the standard deviation, 0.97, and depending on the rounding they want on my math lab. Okay, so that's that part of it. And then the very last thing we have to do is comment the shape of this distribution. So if we go back to that web page, that looks left skewed, I said. Well, what happens if we increase our, what happens if we increase our size, the number of trials? I mean, what if I jump to 10? Does it still look left skewed? Well, not quite so much. How about 50? It's starting to look like a normal distribution, or a bell curve distribution. In fact, if we go back to 30, it still looks like a bell curve distribution. If we go to 25, it's starting to see a little skew. This number 30 is kind of a magic number you're going to see later on. Okay? So, but what I want you to understand about this is these binomial distributions, if you run enough trials, they approach normal distributions, and that gives us a lot of that gives us a tool we can use later on. In fact, in week 8 we'll be looking at it. Okay, so that's why one reason why these binomial distributions are important. You can start getting bell curves and using all those empirical rules and other tools with them. Okay, so I hope this helps you and takes some stress off this chapter for you.